At 09:14 a.m. on June 7, 1943, a P-38 Lightning rolled to a stop on the Coral Runway at Dobodura, New Guinea. Its twin Allison engines ticked as they cooled, sending heat shimmer into the air. Ground crew gathered around the fighter, staring at the warped metal of its tail section. The pilot climbed out without a word. His face said enough. Controls had locked again in the dive. Another aircraft saved by altitude, not by design. Compressibility, they called it. A word from engineers thousands of kilometers away that meant nothing to the men who kept these planes alive. Dobodura's fighter strip was a patch of pierced steel planking laid over a swamp, white dust rising with every step. The smell of oil, sweat, and salt never faded. For weeks, the same report came back from every squadron. At high speed, the Lightning's controls froze solid, turning each dive into a death sentence. Engineers blamed physics, pilots blamed the aircraft, mechanics blamed the manuals. Out here, nothing in print could keep a man alive at 480 miles per hour. That morning, a crew chief crawled beneath the tail boom of a battered P-38 and studied the elevator linkage. Under strain, the bracket flexed almost invisibly, a fraction of an inch that multiplied when the aircraft dived. He reached for a coil of safety wire, the kind used to secure fuel caps. The fix took less than 10 minutes. A loop through the lever, twisted until tight, crude but firm. It violated every regulation in the maintenance handbook. But when he pressed the control surface by hand, the movement felt different. Smoother, cleaner, solid. Later that day, the pilot who had nearly died asked to take the same aircraft back up. The others watched as he lifted off into the white heat, climbing until the silver outline vanished into cloud. 10 minutes passed. Then the sound returned, engines descending, throttles wide open. The Lightning leveled out low over the strip and roared past in one piece. The pilot's hand rose from the cockpit. Thumb up, a small gesture lost in propeller wash. That night, no one in the tent said much, but every man remembered the moment. A few inches of wire had turned uncertainty into control. No one wrote it down. No one asked permission. The next morning, more aircraft rolled into the shade, tails open, tools ready. What began as one quiet experiment was already becoming doctrine, passed hand to hand through men who didn't wait for approval. Out here, survival often began with a question no report could answer. How many lives depend on the smallest things we fix ourselves? Chat GP Janoi. By mid-morning, the flight line at Dobodura was alive again. Mechanics moved between the parked Lightnings like surgeons in oil-stained uniforms, their faces burned by the sun, their hands wrapped in rags blackened from hydraulic fluid. The war in the air was accelerating faster than the engineers on the ground could keep up. Every day brought new orders, new bulletins, new instructions from offices thousands of kilometers away, none of which stopped the aircraft from breaking under strain. In the first half of 1943 alone, more than 40 P-38s had been lost in unexplained dives. Command blamed pilot error. Pilots blamed physics. The truth lay somewhere in the vibrations that shook every tail when speed passed the limit of what aluminium could bear. On June 10th, a flight of 4 Lightnings lifted off for a routine patrol over the Huon Gulf. The air was clear, the sky thin and sharp. 10 minutes into the mission, one fighter entered a shallow dive after 2 zeros. The Japanese broke away easily. The Lightning kept descending. Witnesses saw it hold straight and rigid until it hit the sea in a column of white spray. No radio call, no ejection, just silence. The pilot's name was entered on the morning roll as missing, presumed dead. His aircraft became another statistic, another line in a report marked Cause Unknown. That evening, pilots gathered in the mess hut. They spoke in short, tense sentences. Every man knew what had happened. No one could explain why. The flight surgeon called it nerves. The engineers called it shockwave formation. The veterans called it suicide. One of them said quietly that even if you pulled with both arms, the stick wouldn't move. The room fell silent. Out here, no one wanted to talk about death that came from the aircraft itself. While pilots argued, the mechanics kept working under floodlights that turned the strip white. They cut safety wire, tightened bolts, adjusted cables by touch. A few of them began copying the brace they had seen under one Lightning's tail. A field trick, nothing official, just a loop of steel that kept the linkage from flexing. They didn't talk about it much. They simply wired every aircraft that passed through their hands. The work was silent, repetitive, unrecorded. But the men doing it understood what they were changing. 3 days later, the squadron's commanding officer took one of the modified fighters up himself. He climbed to 25,000 feet, then pushed into a dive, eyes fixed on the trembling airspeed needle. At 470 mph, the controls stiffened, but did not freeze. He pulled gently, leveled at 12,000 feet, and came home shaking. The test was unofficial, undocumented, but it spread faster than any memo. Within a week, 5 squadrons were wiring their aircraft the same way. The results showed almost immediately. Pilots began to dive harder, to fight back instead of breaking away. The Zeros that once ruled the lower sky started losing their advantage. Reports came in of successful pursuits where the Lightning held its shape instead of shuddering apart. The fix didn't eliminate compressibility. It bought a few seconds of control, enough to live. For the men flying, those seconds were the difference between a mission and a memorial. Command still refused to acknowledge the modification. They said it violated procedure, compromised flight testing, endangered pilots, but no one in the field cared. The Pacific was full of dangers already. A piece of wire wasn't the worst of them. Each aircraft that survived a dive became proof of something larger than any order could suppress. Word spread through supply chains, through maintenance tents, through pilots talking over coffee in the dark. By the end of the month, the wire trick had become a quiet rebellion against the limits of theory. A change born not from command, but from necessity. And as June turned to July, the Lightning's reputation began to shift. The same machine that once killed its own pilots was slowly becoming the weapon it had been promised to be. It wasn't magic or engineering brilliance or luck. It was the smallest change, made by the men who refused to wait for permission. By the last week of June 1943, the field modification had become an open secret. No one had written it down, yet every mechanic knew exactly how to do it. The procedure spread by memory, gesture, and habit. A man would watch another twist the wire, hear the faint metallic tone it made when plucked, and understand without needing explanation. The Pacific didn't need blueprints. It needed things that worked. The effects appeared in every mission log. Pilots who once avoided high-speed dives now used them deliberately. Reports from the 5th Air Force noted improved stability and pilot confidence. The phrase meant everything and nothing, a bureaucratic understatement for lives saved. Aircraft that had been grounded for tail flutter were flying again, patched, scarred, but reliable. A single loop of wire had done what months of official testing had not, made the Lightning safe. Each squadron that adopted the fix claimed it had discovered it first. At Port Moresby, they called it the linkage lock. At Milne Bay, it was the wire brace. At Dobodura, they didn't bother naming it at all. The mechanics there just said, "We wired it." They worked through monsoon rain and suffocating heat, opening tail sections, threading wire through corroded brackets, and tightening it by feel. There was no measurement, only intuition. The best mechanics could tell the right tension by the note it made. Too dull, and it would fail. Too sharp, and it would shear. In the cockpit, pilots began to notice the difference. The stick no longer fought them in a dive. It resisted, but it moved. The first time a Lightning pulled out at full throttle without shuddering, the pilot radioed 2 words: "Controls solid." It became the unofficial signal that the modification worked. Whenever that phrase appeared in a mission report, every man on the flight line knew that another piece of wire had proved its worth. Lockheed's engineers, thousands of kilometers away, had no idea any of this was happening. They were still drafting theoretical solutions: stiffer control linkages, dive recovery flaps, aerodynamic revisions. None would reach the front until late 1943. The war simply couldn't wait. Out here, time was measured in takeoffs and returns, not in memos and prototypes. Occasionally, official inspectors arrived to collect data. They photographed aircraft, measured vibrations, asked polite questions, and left without understanding what they were looking at. The mechanics never mentioned the wire. They didn't hide it. They just didn't bring it up. To them, it wasn't a modification anymore. It was part of the airplane. By July, the pattern was unmistakable. Losses from dive failures had dropped sharply. Pilots trusted the Lightning again. In combat over the Bismarck Sea, pairs of P-38s dove through formations of zeros, firing, pulling up, rolling away clean. For the first time, American fighters were dictating the pace of battle. Japanese reports described the Lightning as faster in the fall, steady in the climb. The machine that had once been feared for its flaws was now feared for its precision. Word reached Townsville and Brisbane, where 5th Air Force maintenance officers filed cautious summaries. Field reinforcement appears to improve elevator stability at high dynamic pressure. The phrase was careful, almost apologetic, but it was the first acknowledgement that the field had solved what the factory could not. For the men at Dobodura, none of that mattered. They were too busy keeping their machines alive in conditions no engineer had ever imagined. Coral dust that ate bearings, salt air that corroded cables, humidity that turned metal to rust. They didn't think of themselves as innovators. They were just tired of seeing wreckage. Every successful landing felt like a personal victory against physics. At night, when the air cooled and the lights on the strip went dim, they would sit on ammunition crates and listen to the sounds of engines winding down. Somewhere in that hum was the wire, singing quietly through the tail of every aircraft. It was a small sound, but it meant something that charts and equations never could. It meant control restored, lives extended, faith rebuilt. And though no one could name the man who had done it first, every Lightning that came home carried his idea in silence. The Pacific War was full of inventions like that, unrecorded, uncredited, but indispensable. They began as improvisations, survived as habits, and ended as doctrine. This one was no different. A few inches of wire, twisted by hand, had become the difference between an aircraft and a memory. By the first week of July 1943, the rumor had already crossed islands. Crews at Nadzab, Leh, and Oro Bay were wiring their Lightnings the same way, guided only by word of mouth and instinct. No one had written instructions. No one needed to. The fix had become folklore, a single, repeatable act that everyone understood. It was whispered across flight lines, shouted over engines, passed along with spare parts and cigarettes. "Make sure it hums," they said. That was all. The transformation was immediate. Pilots who had once approached dives like gamblers now flew them with confidence. Reports from the 5th Air Force began to show the pattern: fewer losses, faster engagements, longer missions. "Aircraft handling markedly improved," one summary noted. "No further incidents of control lock." Those dry words concealed the revolution happening across the theater. The Lightning had been reborn, not through design bureaus or test centers, but through men with wire and pliers in their hands. Dobodura's line mechanics still worked under the same brutal conditions. The monsoon had turned the strip to mud, and the nights smelled of fuel, sweat, and mildew. They repaired bullet holes with scrap aluminum, patched fuel tanks with tape, and rebuilt engines with salvaged tools. Yet in every tail section, the same wire gleamed faintly under the work lights. It was as if the aircraft themselves were learning resilience from the men who fixed them. The fix worked because it was simple. The P-38's dual elevator system was linked by cables that stretched unevenly under load. At high speeds, the misalignment caused one elevator to lag behind the other, twisting the tailplane and locking the control column. The wire brace held the geometry true, preventing the tiny flecks that multiplied into disaster. It didn't defy aerodynamics. It merely delayed the point where physics won. To an engineer, it was crude. To a pilot, it was salvation. On July 8th, a formation of 12 Lightnings encountered a larger force of Japanese Zeros over the Huon Gulf. The fight lasted 9 minutes. When it was over, 5 Zeros were gone, and every Lightning had returned. In their debriefs, the pilots used the same phrase again and again: controls solid. That night, maintenance crews checked each aircraft and found the same thing. The wire still tight, the tone still singing. Headquarters in Brisbane dispatched a Lockheed liaison officer to investigate. He arrived with notebooks, calipers, and a mandate to enforce procedure. On the first day, he watched as mechanics opened a tail boom, revealing the unauthorized modification. He said nothing. The next morning, he flew one of the wired aircraft himself. The test lasted 20 minutes. When he landed, he tore out the page of notes he had written and replaced it with a single line: field brace effective. Continue as standard practice. That unofficial approval spread faster than any command. Within 2 weeks, depots from Port Moresby to Townsville were wiring new arrivals before first flight. The modification took less time than an oil change and saved far more lives. It became as instinctive as checking fuel or ammo. By the end of the month, pilots in every Lightning squadron across the Southwest Pacific were flying aircraft bound together by the same loop of steel. The engineers back home finally learned about it when damaged aircraft were shipped stateside for overhaul. They found the wires, tested the stress loads, and confirmed what the field already knew. Elevator flutter reduced by nearly 30%, dive recovery improved, pilot confidence restored. Lockheed's official bulletins rephrased it politely. Interim field solution demonstrates effective mitigation of high-speed control anomaly. In plainer terms, the mechanics had fixed the problem before the designers could. Out on the islands, the men didn't read the bulletins. They were too busy keeping aircraft flying through rain and exhaustion. For them, the reward wasn't recognition. It was the sound of engines returning at dusk, when the Lightnings came back in formation, cutting through the clouds with their twin tails glowing in the setting sun. The ground crews felt something close to pride. The machine that had once betrayed them was finally keeping its word. One evening, as thunder rolled over the jungle and the flight line shimmered with heat lightning, a pilot left a note wedged under the flap of a maintenance tent. It read simply, "Still diving, still alive, wire held." The mechanics never learned who wrote it, but they passed it around anyway, grease-stained and folded until it fell apart. It was all the recognition they would ever need. By late July, even the most cautious officers had stopped questioning the modification. The numbers spoke too clearly. What had begun as an act of quiet rebellion had become regulation through necessity. The Lightning's reputation was no longer that of a flawed machine, but of a fighter that learned from its own mistakes. And in the long chain of cause and effect that defined war, that wire, twisted tight under a mechanic's hand, was becoming something more than metal. It was belief turned into steel. By August 1943, the results were no longer deniable. Combat reports from New Guinea, the Bismarck Sea, and the Solomon Islands all told the same story. Fewer accidents, cleaner dives, more victories. The P-38 Lightning, once whispered about as a death trap, was becoming a weapon pilots trusted with their lives. Officially, the cause was still listed as tactical improvement. Unofficially, everyone knew it was the wire. The 5th Air Force Command Staff began compiling data. From April to July, lightning loss rates in dive maneuvers had dropped by more than 40%. Pilots described the aircraft as steady, predictable, and responsive. Those words had never appeared in a P-38 report before. For the first time, the Lightning was being flown to its potential. A 600-kilometer-per-hour interceptor that could outclimb bombers, outrun Zeros, and survive its own speed. The change rippled upward through the ranks. Major Charles Lindbergh, visiting the theater as a civilian consultant, inspected a Lightning at Dobodura and noticed the wire running through its tail bracket. He asked what it was. The mechanic who'd installed it hesitated, expecting a reprimand. Lindbergh traced the line of the wire with his finger, nodded once, and said only, "Simple works." The next morning, he flew a P-38 modified the same way, dove past 480 miles per hour, and returned grinning. His notes on the test would later reach Lockheed's engineering office in California. At the same time, maintenance crews in other air forces began hearing of the trick. Australian units at Port Moresby, American groups in the Aleutians, and even a few British observers copied the idea. It spread without official sanction, carried by rumor and trust. Field maintenance, it seemed, had become the world's fastest courier service. The simplicity of the wire fix made it impossible to control. Any mechanic with a spool and a wrench could reproduce it. There were no special materials, no blueprints, no training courses. Its strength lay in its ordinariness, a repair that could be done anywhere, in any weather, by anyone who understood what the aircraft needed. It turned a design flaw into a shared solution, a kind of unspoken brotherhood among the men who kept machines flying. As August wore on, the weather turned worse. The monsoon soaked the airfields, grounding half the fleet. When the skies cleared, the Lightnings went up again and came back without a single loss. Pilots began pushing the limits, diving steeper, faster, trusting the aircraft completely. The Japanese noticed. Radio intercepts mentioned American twin-tails now dive like demons. For the first time since the start of the war, the Zero's myth of invincibility was cracking. At Dobodura, the change was visible even to outsiders. Fewer wrecks littered the perimeter. More aircraft lined up for missions than for repairs. Mechanics still worked around the clock, but the tension had shifted from fear of failure to the relentless drive to keep perfection intact. The sound of wire tightening had become part of the base's rhythm, a small metallic cord that meant life instead of loss. Lockheed's liaison officers finally reported the results to their superiors in the States. The company's engineers confirmed that the wire brace reduced elevator twist by nearly 1/3 and delayed compressibility onset by several seconds. It wasn't a permanent fix, but it bought time enough for pilots to pull out of dives that would otherwise have killed them. Lockheed issued Bulletin 278, acknowledging the temporary field adaptation. The language was clinical, but its meaning was revolutionary. For the men on the flight line, the bulletin meant little. They had known the truth for months. The Lightning no longer fought its pilots. It obeyed them. The fix had transcended its material form. It had become a lesson in how wars are really won, not by design perfection, but by persistence. On the 1st of September, the squadron moved north toward the Solomon. Before departure, the maintenance chief walked the line, tapping each tail section once with his wrench. The sound that came back was the same clear note he'd learned to trust. Each aircraft sang in its own pitch, proof that the geometry held, that the machine would endure. The men had come to believe in that sound the way soldiers believe in luck. When the convoy lifted off that morning, the Lightnings climbed into the overcast in pairs, their contrails twisting into a single white spiral. The crews watched from the ground until the sky swallowed them. Then they went back to work, already preparing the next batch of aircraft. None of them spoke about innovation or credit. They didn't have to. Every engine that faded into the clouds carried the same small miracle. Steel wire, twisted tight, humming quietly beneath the skin of a fighter that had learned how to survive. The Solomons campaign tested every promise the Lightning had made. By October 1943, the 475th Fighter Group was flying long-range escort and interception missions from Dobodura to Bougainville, runs that stretched pilot endurance and machine limits to the edge. Each sortie meant hours over water, sudden weather, and the constant threat of Zeros rising from the sea. For the P-38, this was the crucible. The wire fix had saved lives in tests and small engagements. Now it would face the only test that mattered, combat at full speed. On October 23rd, 12 Lightnings climbed into a dawn sky streaked with thin cirrus and turned north toward Rabaul. Radio chatter crackled through the headsets. Enemy formations ahead, 24 aircraft. The American flight split into pairs, climbing into the sun. The Zeros came up in perfect formation, banking hard to meet them. The first passes were a blur, machine gun flashes, contrails twisting through sunlight. 2 Lightnings dove to escape the melee, engines screaming. For the pilots, that moment had always been the line between life and death. At 460 miles per hour, the controls of the old, unmodified P-38 would have frozen solid. But now the stick moved, heavy but responsive. The aircraft obeyed. One pilot, his name lost to history, rolled inverted, pulled through the dive, and came up behind a Japanese fighter. The Lightning's nose guns barked, and the Zero disintegrated into fragments of wing and smoke. He pulled out cleanly, level at 10,000 feet. When the formation returned to base, they were missing none. Mechanics counted 200 bullet holes, spread across the 12 aircraft. Not one in the tail section had caused a control failure. In his report, the squadron commander wrote, "Controls held firm in all dives. No lock observed." It was the first written proof that the field modification had turned survival from chance into certainty. The victories multiplied. The Lightning's reputation, once tarnished by physics, now gleamed with numbers that even the skeptics could not ignore. Kill ratios flipped. Losses plummeted. Japanese pilots who once mocked the heavy twin-boom fighter began calling it the double shark. On the ground, no one celebrated loudly. The men simply nodded, rechecked their work, and moved on to the next mission. They had found a balance between confidence and respect, a silent understanding that the aircraft owed its life to the care behind the scenes. Lockheed's engineers followed the reports from afar, reading about maneuvers that shouldn't have been possible with the original design. They knew something in the field had changed. Requests for documentation piled up. None came. Out in the Pacific, the mechanics were too busy keeping the machines flying to explain how. By the time Lockheed's official dive flap kits arrived, the war had already adapted without them. Through the end of the year, the Lightning became the spearhead of Allied air superiority. Escorting bombers over the Philippines, sweeping Japanese convoys in the Bismarck Sea, the aircraft now dominated altitudes where the Zero once ruled. Pilots spoke of dives that felt effortless, recoveries that felt like instinct. Some swore they could sense the tension of the wire in their fingertips as they pulled the yoke, a faint resistance that felt alive. Even with its success, the modification remained invisible. Official communiques credited aerodynamic refinement and pilot training. None mentioned the loops of wire hidden beneath panels or the hands that had twisted them in the dark. The Pacific War was too vast for recognition to travel backward. But in every hangar from New Guinea to Guadalcanal, the men who kept those aircraft alive knew the truth. The Lightning's transformation was complete. It no longer belonged to the engineers or even the officers who signed reports. It belonged to the crews who had refused to wait for permission. Their work didn't end when the missions did. Each night, under makeshift floodlights, they opened the tail booms again, tightening the same brackets, listening for the same hum that had become their quiet assurance against gravity. That sound, a single metallic note, faint but steady, carried through the night air like a heartbeat. It was the proof that everything held together, that steel and will could coexist. Above the jungle, under the same stars that marked every Pacific battlefield, the Lightnings cut their thin white arcs through the dark, carrying a secret no one could hear but everyone depended on. By early 1944, the transformation of the Lightning was undeniable. From the Solomon Islands to the Marshalls, the same reports kept arriving. More missions flown, fewer accidents, and pilots who trusted their aircraft again. In 1 year, a fighter once known for killing its own had become the backbone of the Allied advance. The wire fix, still unnamed in official dispatches, had worked its way so deeply into daily practice that no one thought of it as a modification anymore. It was simply part of the airplane. At Nadzab, New Guinea, a new squadron arrived fresh from the United States. The pilots had been trained on the latest Lockheed specifications, updated control systems, reinforced linkages, and the newly installed dive flaps. But when they met the men who had been fighting here for a year, they learned another rule. Before their first combat mission, each aircraft's tail section was open, inspected, and quietly wired. Just insurance, the older mechanic said. No one argued. The airfield was a mix of noise and exhaustion. Engines coughed and whined in the humid air, and rain turned the runway into a film of mud and coral dust. Mechanics slept in shifts, waking only when the sirens signaled an incoming flight. Their tools were worn smooth from use, their fingers calloused from safety wire. But in every hangar, in every tent, the same ritual repeated: tighten, test, pluck. The faint metallic hum that followed was the new language of reliability. The war had changed as much as the machines. American forces were advancing north through the Pacific, island by island. The Lightning, with its range and twin engines, was now the escort fighter that could keep up with bombers all the way to the Philippines. On those missions, pilots depended on the fix they could neither see nor name. It gave them the confidence to dive through Japanese formations, break free, and climb again. The air war was no longer about avoiding compressibility. It was about mastering it. In February, 5th Air Force Command compiled a statistical analysis. The numbers were stark. In 12 months, control-related losses in the P-38 had dropped by 90%. Kill ratios had tripled. Combat readiness, once crippled by fear of dives, now exceeded every expectation. The official explanation credited aerodynamic refinements and operational adaptation. The truth remained unspoken. A few inches of wire had rewritten the odds. Lockheed's engineering division, now aware of the field modification, began incorporating its logic into their designs. Stronger brackets, tighter control linkages, and hydraulic assists all carried the DNA of that crude field solution. But the company's official bulletins remained cautious. They couldn't admit that the battlefield had beaten them to the answer. So they described it as convergent development, two paths reaching the same result from opposite directions. For the mechanics who had started it, none of that mattered. Their work didn't change, only their confidence. They could look at the fighters lined up at dawn and know each one had a better chance than the last. When the lightnings took off, engines echoing across the valley, the men would stand and listen for the rhythm of synchronized power. They didn't need ceremonies or praise. Survival was the only proof that counted. In the months that followed, the fix spread far beyond the Pacific. Word of it reached P-38 groups in Europe through maintenance correspondence and pilot rumors. Crews at English bases began wiring their aircraft the same way before escort runs over Germany. The idea crossed oceans without paperwork or permission, carried by the same instinct that had borne it. If something works, you pass it on. By the summer of 1944, every Lightning in service carried some form of the reinforcement, official or otherwise. The aircraft had outgrown its early fears. The men who flew it no longer looked down at the ocean in dread. They looked forward into cloud, into combat, into the future. The war was changing again, and the P-38 was changing with it. Few of them knew or cared where the fix had begun. It didn't matter anymore. What mattered was that the machine obeyed, the wire held, and the pilots came home. And in the end, that small act of defiance against procedure had become something larger, a quiet symbol of how wars are truly fought and won, not by permission, but by persistence. By the middle of 1944, the P-38 Lightning had become the face of Allied air power in the Pacific. It flew escort for bombers over the Philippines, struck convoys in the Bismarck Sea, and hunted enemy reconnaissance planes across thousands of kilometers of ocean. On paper, its performance looked like the triumph of engineering, the product of refined aerodynamics and precision manufacturing. In truth, its reliability came from a handful of mechanics who had refused to let a design flaw decide who lived and who didn't. The war's numbers told the story clearly. In 1942, nearly 1 in every 10 Lightnings lost in combat had gone down from control failure. 2 years later, that number was less than 1 in 1,000. Mission completion rates climbed past 90%. The official reports praised improved maintenance protocols and pilot training, but between the lines, everyone knew what had changed. A field modification that no one had authorized had quietly become standard practice. Even Lockheed's own test pilots noticed the difference when refurbished aircraft returned to the States for overhaul. They found the faint marks of drilled holes and loops of safety wire that weren't part of any blueprint. The company's engineers measured the results and confirmed what the field reports already proved. Elevator twists reduced, flutter delayed, and compressibility dives controllable at higher speeds. They folded those lessons into the next production runs without crediting their origin. The new models looked sleeker, cleaner, more efficient, but hidden beneath the panels was the same idea born on a muddy strip in New Guinea. At forward bases, the men who had first wired the aircraft kept working with the same discipline. They had no time for history or legacy. Their job was to keep machines alive long enough to bring people home. Each evening, they ran fingers across taut metal lines and listened for the single note of tension that had become their measure of safety. They still called it by no name because names suggested ownership, and this idea belonged to everyone who had ever twisted a piece of wire to stop something from shaking itself apart. The Japanese pilots who once laughed at the heavy American twin tails were now calling them the double demons. Their reports described P-38s that dove like falling stars, rolled level, and climbed back through the cloud before Zero could react. The balance of fear had shifted. What had started as an improvisation had become an edge that no enemy could erase. When the 5th Air Force compiled its year-end analysis, It credited the Lightning's success to a combined evolution of design and field ingenuity. That phrase, bland and bureaucratic, was the closest any document came to acknowledging the truth that the aircraft's most critical improvement had never passed through a drawing board. It had started with a question, a risk, and the refusal to accept that failure was inevitable. By late 1944, new P-38 models with factory-installed reinforcements were arriving in theater. Official orders directed crews to remove all unauthorized modifications, but no one complied. They left the old wire in place, buried beneath the new fittings, a silent insurance policy. To them, progress was only trustworthy when it carried the memory of what had worked before. The Lightning story had become a paradox of modern war. Its victories were recorded in statistics, but its salvation was measured in the quiet, invisible work of men no history book would name. In a world driven by design and doctrine, the most important solution had come from the ground up. And so the fighter that once symbolized the limits of human control now stood as proof that those limits could bend. The P-38's strength was not just in metal or horsepower, but in the hands that refused to surrender to physics. By the time the war turned north toward the Philippines and the Japanese homeland, that lesson had already written itself into the Lightning's frame, a legacy of wire, will, and the belief that perfection often begins as repair. When the war ended in August 1945, the P-38 Lightning had flown more missions across the Pacific than any other American fighters. It had escorted bombers over Rabaul, attacked shipping in the Philippines, and fought over Luzon and Okinawa. Its twin tails became a symbol of distance conquered, of reach and power. Yet the story of how it had been saved, how its most dangerous flaw had vanished, was never written into its official history. The war moved too quickly to remember where solutions began. At air depots in the months after victory, engineers examined the returning aircraft. Many were scarred by combat, patched with aluminum plates, streaked with oil that no cleaning solvent could erase. Under the tail panels, they found the same thing on almost every airframe. A loop of wire, darkened with age, still tight. Some of the newer models had the factory fix installed beside it. 2 generations of engineering sharing the same space. Most inspectors removed the wire without comment, tossing it into bins marked scrap. None could say who had first thought to twist it there. Pilots going home to civilian life told stories of dogfights and long escorts, of engines that never quit and aircraft that always pulled out of dives. Few mentioned the wire. Fewer still knew it existed. The men who had wired those machines kept no records. They had never seen themselves as innovators, only as caretakers of something that needed to work one more time, for one more flight. The Lightning itself faded quickly from service, replaced by jets that could outrun sound and altitude. Museums restored a few of the old fighters, polished them until they gleamed. Visitors saw smooth metal and perfect rivet lines. They didn't see the drilled holes beneath the skin or the ghost imprint of steel that had once held the aircraft together. But in some of those airframes, quiet, forgotten, fragments of that wire still remain, buried inside the tail, holding shape long after the last engine stopped turning. Official history called it evolution. The men who lived it knew better. Progress had not arrived from factories or laboratories, but from a handful of mechanics who refused to accept that failure was inevitable. The P-38's victory over its own flaw had been born not from invention, but from stubbornness. In every sense that mattered, it was a human story disguised as a technical one. The wire didn't change the war by itself, but it changed the way men saw the machines that carried them. The belief that even perfection could be improved, that no design was beyond repair. That idea outlived the lightning. It still hums quietly in every workshop where someone refuses to leave a problem unsolved. War is often remembered through grand strategy and great names, generals, aces, engineers. But the truth lives somewhere smaller. It lives in the space between a wrench and a heartbeat, in the hands of men who never expected to be remembered. The story of the lightning's wire is one of those moments that slips through the cracks of history because it has no hero, no speech, no photograph, only results. Sometimes I wonder how many wars have turned not on design or command, but on a single act of persistence. A bolt tightened a little harder, a gauge recalibrated because someone couldn't stand to see it off-center. A wire twisted through metal because a man refused to let the next pilot die for the same reason as the last. Those things don't make headlines. They make survival. Maybe that's why this story lingers. It reminds us that progress isn't always innovation. It's endurance. The Lightning didn't become legendary because of its engines or its speed. It became legendary because ordinary people refused to accept that good enough was good enough. Their defiance turned into design, their improvisation into doctrine. We live surrounded by machines born from that same stubbornness. Every improvement hides a quiet lineage of hands that solve problems no one had planned for. The P-38's wire was one of them, unrecorded, uncelebrated, yet essential. It carried not just a machine, but a lesson, that the future often begins as repair. So when I see an old lightning in a museum, polished to perfection, I think less about what it achieved and more about what it survived. Beneath that metal lies a question that still deserves to be asked. How many of the world's miracles begin as someone, somewhere, refusing to wait for permission to fix what's broken?